Hey, hi everyone. Welcome to the Strange Danger. Today, the session, the JavaScript attack surface just got bigger. But today we have a special edition. We're doing the Big Fix edition. So let's have a look at first, because you might be wondering, what is the Big Fix? So the Big Fix is basically our month-long fix-a-thon. It started during the Valentine's Day, February 14th, and it runs until March 14th. And during this month-long fix-a-thon, you can actually win prizes for fixing vulnerabilities in open and closed source software while making a positive impact. So how does it work? So basically, when you go to this page, let me just share it with you here. Cool. So when you go on this page, you can actually sign up and start fixing. So you give your first name, your last name, your email, you submit, and then you'll get an email. Then you can start fixing the security vulnerabilities that you have within your projects. And also, there's a leaderboard. Why is there a leaderboard? Because if you fix vulnerabilities and you manage to get to the top 3 places, then you can have a VR headset, if you manage to get the first place, a wireless speaker for a second place, and an Arduino story kit for the third place. But the good news, if you fix at least one vulnerability, you'll get a limited edition T-shirt. How cool is that? You'll get this T-shirt, I think. So the goal for this year for us is to fix at least 200,000 security fixes. And as of today, we actually, all of us fixed 150K security fixes, which is amazing. But we need to continue and fix more security vulnerabilities. And also, you can have a look at the leaderboard. Also, yesterday, we had our live stream schedule. And if you miss it, maybe you were doing other things, but you actually want to watch all of these amazing sessions and topics that we had for the APJ, for EMEA, and for Mirror Track. The good news is all this has been recorded, and you can actually watch them on the Snyk YouTube channel. So if you go to the Snyk YouTube channel, I'm just going to share the link here. So if you go on the Snyk YouTube channel, you can see all of this, the Big Fix videos from this year. So this has been recorded. We're working behind the scene to actually cut all of the sessions, and you have everything prepped in a specific playlist. But until then, we do have a few interesting sessions that we had. So last week with Vandana, we did, for example, the OWASP Top 10, Snyk Path, if you want to learn more about those around the Snyk. We also have series around the other JavaScript. Attack surface just get bigger, other Stranger Danger. Also, we have the Java flavor of this session and others. Cool. So back to where we are at today, the stranger danger. Your JavaScript attack surface just got bigger. So I'm Sonia Moise. I'm a senior security advocate here at Sneak, and I'll be your host for today. So what are we going to talk about today? First of all, we're going to have a look at the current state of open source software. We're going to have a look at the iceberg, and you might be like the little emoji saying, what is she talking about? But I'll explain. We're going to have a live hacking session with Patch, because Patch came today as well. It's going to help us fixing vulnerabilities, and hopefully we're going to learn a few things along the way. So let's start with the current state of open source software. So we know that organizations of all sizes are heavily reliant on software. Much of that software consists of a lot of open source software components. Thus, OSS has cybersecurity implication because this is an attractive endpoint for attackers who are interested in theft, disruption, or exploitation for economic or political gain. Thus, we have the attack surface is changing. Actually, it's getting bigger with all of that. And we've seen that defects in small libraries can cause systemic risks. And we've seen 2 years ago with the incidents such as Log4Shell. So why application security is important? We know that vulnerabilities can originate from something as simple as a config error or using a software component that contains a known vulnerability, which is why maintaining and improving application security is so important for businesses. One recent study revealed that out of 85,000 applications that were analyzed, 83% contain at least one security flaw, and of these, 20% has a severe vulnerability. So while not all of these vulnerabilities necessarily present a major risk, hackers continue to refine their attacks by using ingenious workarounds to penetrate softwares. And you have organizations such as OWASP, which stands for Open Worldwide Application Security Project, that tracks vulnerabilities found and provide a list that developers and security teams can use as a starting point for their security application program. So the most recent one, the OWASP Top 10 list, was released in 2021 and included vulnerabilities like broken access control, injection attacks, security misconfigurations, and others. So let's have a look at some of the open source software attacks. The first one is typo squatting attacks. So typo squatting attacks takes place when bad actors push malicious packages to your registry with the hope of tricking users into installing them. So this is really similar to website phishing attacks that exploit typos made by individuals who may accidentally typing a wrong address. So here we have an example with the package React with a typo. And in that case, you'll not install React, but you will install a malicious package that has a completely different end goal. And usually those packages want to capture environment variables and send them to the attacker's control remote server. Another example is malicious packages, which inject malicious code into a software product in order to compromise dependent systems further down the chain. So in this example, we're having a package called Fall Guys. And usually the malicious actor will try to surf on trends. And in that case, because the game has been quite popular during the pandemic, users might think that by downloading this package, they'll have an advantage in the game. Let's have a look at this one using Sneak Advisor. So Sneak Advisor is a platform where you can actually check packages. So we have a few ecosystems like NPM, PyGo, and Docker. And let's put Fall Guys here. And let's see what we have. So here we can see that this is a malicious package, and that's the package that I'm talking about. And here, using Sneak Advisor, you can actually see if those packages are malicious or if they have security vulnerabilities, if they're well maintained. So you have this kind of information. So in that case, Fall Guys was a malicious package that contains malicious code that attempts to read local sensitive file and exfiltrate information through a Discord webhook. So that was the entry point. The Discord webhook was the entry point. And the code attempted to access specific path available on Windows systems. And it was looking at the local storage level DB. One last example is compromising maintainers, where malicious actors will use social engineering methods to gain access to open source projects. So here we have an instance with the event stream package where the malicious actor did social engineering the maintainer. So at first, the attacker went through all of the issues within the repository. He was looking at some code where he could contribute to, and he started pushing some cosmetic changes at first, just to build up the trust with the maintainer. And once he got more permissions, he pushed his malicious payload into the code base. And he was targeting a Bitcoin wallet in that specific case. So his modus operandi was quite interesting in going through all the issues, see if he can contribute and be trusted, and then push his code. So this is known as a supply chain attack, also called third-party attack. It occurs when someone infiltrates your system through an outside partner or provider with access to your systems and data. It doesn't affect only JavaScript packages. This is an issue for all ecosystems. And we had a recent example with Log4Shell within the Java community with vulnerability in the open source Apache Log4 logging library, where one of the Log4j exploits allow remote code execution on the servers running vulnerable application without requiring authentication. And that has earned the vulnerability severity rating of 10 on the CVSS scale, which is the common vulnerability scoring system. So Log4j is used in many commercial applications, and sometimes organizations might be vulnerable without knowing that they are actually using the logging library. So supply chain attacks are quite attractive to hackers because when commonly used software or packages are compromised, the attacker could potentially gain access to all of the enterprise that use that software. So let's try to understand how this is possible, and let's say hi to the iceberg. Hi. And if you're confused by that statement, let me explain it to you. So that's the iceberg. And usually the iceberg is used as an analogy to understand the layers that we have within our code base. So our starting point is our code. This is the proprietary code that we could write potentially in an organization. Does it bring security vulnerabilities in our code base? Maybe, maybe not. Let's see. In that specific example, so what we're having a function signature of an express application with a function that has a request, a response, and an X callback. So this is trying to call the user table or collection. So it means that there's a database behind the scene. And it's trying to do a login, so looking for the username and the password. So what could be the vulnerabilities here? What can go wrong? So here we have an example of a database injection, and more specifically, a NoSQL injection. So applications which are built with Express will have body parser that is used to parse the JSON object and takes whatever you send to and convert it as a JavaScript object. If the request has a username and a password, this is going to be part of the JavaScript object. And if you're using MongoDB and add the $sign greater than as a key and an empty string as a value, the JavaScript object will tell MongoDB to do a greater than match to filter all the results. So for example, if you send a request with admin as the username, this object will perform a NoSQL injection in this piece of code, and you'll be logged in as an admin. This shows the importance of sanitizing inputs and to handle this as soon as possible before it is stored in your database. This is another example of importing, for example, a dependency, which is actually a nice segue to layer below the application code on the iceberg. The open source code. So if we think about how many lines of code we write ourselves versus the number of packages we import to cut down the time we spend coding, we don't want to reinvent the wheel, and this is totally understandable. Why would we want to waste some time to rewrite something that might probably exist as a package in our ecosystem? That's what we have here with the marked package. But now we're bringing several packages into our code base, and you can see this with all of the little npm packages in this graph. And this is increasing the attack surface and introducing new risks. Also, we need to keep in mind a few questions. Are we aware of all the packages that we have within our code base? Are we aware of all the dependencies and sub-dependencies? Do we have a good understanding of indirect or transitive dependencies? Do we have tools that help us having that level of understanding and visibility? And most importantly, what are the risks when we bring a dependency into our code base? So I know that's a lot of questions. Let's see some numbers around that. So the average number of outstanding critical vulnerabilities in an application is around 5.1. And obviously, this will change based on your programming language. The average number of top dependencies per project is around 80. But the most concerning one is the last one, actually. The average number of days it takes to fix a vulnerability is around 100 days. So enough chatting for now. And let's move on to hacking an application and understand more about how dependencies can impact your application and introduce vulnerabilities that you are not aware of. So here, I'm going to use a few applications that you could find here. I'm just going to share the links. So we do have a few vulnerable applications that you can actually git clone and experiment with if you want to fix some security vulnerabilities. Just going to, put this. Cool. And so I'm going to use a few of these applications. So this is the first one, the Node.js goof, and this is what it looks like. So basically, I'm going to have like a little scenario in this one. So Patch hired me to actually test this application. So as a pen tester, I'll have a go and test to see if there's any vulnerabilities in this application. So at first, what I'm gonna look at. So when I'm testing an application, I want to see if there's any sensitive files or sensitive info that I can get to. So the first part of this application that I have a look at is the URL. And you might be asking yourself how you can tamper with the URL. What does it mean? What kind of information you can actually get if you actually change some parameters in the URL? So what I'm going to do is, first of all, I'm going to have a look at the source codes, trying to see if I can find anything interesting. I see there's like a public folder. Okay, so let's try this. Let's do /public. Okay, that's interesting. I do have access to a few things here. Okay, CSS, JavaScript, robots.txt. Okay, I'll just continue go up from one folder. And oh, I'm back to the front page. Okay, that's great. So which means that some sort of sanitization in the backend, which is great news. What I'm doing here is actually I'm trying to traverse the directories to try to find sensitive information like credentials or passwords. And I've tried with the .. because usually the .. command is to check the parent directory of the current directory you're in. And we're trying to like navigate up folders. So this is not working, but I do know the .. command usually works. So how can I do this? One way actually to perform the this path traversal vulnerability is to URL encode the .. So URL encoding is basically replacing unsafe ASCII characters with a percent followed by 2 hexadecimal digits. So what I'm going to URL encode here, I'm going to encode the dot, which is going to be the %2e, and the slash with %2f. Cool. So let's try this. I'm going to go back to the public, and just going to make sure that I copy the right one. Here. That's interesting. I actually managed to bypass the sanitization and perform the .. command attack. Cool. So what I have here, so I'm a penetration tester for Patch Ltd, a company. So I'm just looking at ways to improve this application, which I'll actually tell them so they can write. I will write down on my reports. But here I have access to all the files from the application, which helps me, as if I was an attacker, that could potentially help me understand more about the architecture of the application. So let's have a look. I have deploy Heroku Markdown file here that helps me understand more about how they deploy the application. There's a Docker compose YAML file. Let's have a look. Oh, there's actually some passwords here. Okay, writing down all of this in my reports. Dockerfile. Okay. What I'm going to do is have a look at the package.json, because as an attacker, potentially what I can do is look at all of the packages and see if they're using a vulnerable version of the package, so I can potentially tamper with in the application. So here I'm looking at the at the version of the package. So I can see they're using this specific version of Lodash, this specific version of marked, okay, and this specific version of st package. And I'm actually looking at these 3 packages because these are the hacks that I'm going to perform for this this demo. Okay, so this is one piece of information. The other piece of information is probably routes, just to see what they're doing with this application. And looking at some of the routes, I'm going to have a look at the last route, this one. Also, when you push to production, don't let your comments or to-do, because this is a great indication of for potential attacker. So here I'm seeing like there's a prototype pollution demo here. Okay, and I'm going to temper with the chat endpoint at some point. Cool. So this is giving me a lot of information, and I'm going to come back to this, but this is just to show you how an attacker could potentially temper using this this path reversal vulnerability. So let's continue. Let's go up another level. Okay, so obviously because I'm serving this application on my local machine, you can see my folders, and I'm continuing going up from one folder. I have access to etc folders, the bin folder. So yeah, I'm not going to click on this because I don't want to reveal any sensitive files in live, but you get the gist of it. Cool. So what is going on here? So I've seen there's like a few vulnerable packages down what is wrong on some of these packages because they are using specific vulnerable versions. But let's have a look at the code to understand a little bit more what's going on. So for serving static files, the application is using the package ast that you can see here. And it's recorded here at the top. And we are instantiating it here. Cool. And that's why we had access to the public folder. Okay, so I still don't know what kind of vulnerability it is. Well, as a pen tester, I've checked. I know there's a path reversal vulnerability, but I just want to make sure that my assumptions are right. So what I'm going to do is I'm going to go to the marketplace. I'm using the VS Studio Code ID. I'm going to type sneak here, and I've installed it already. But if you want to install this integration, you can go on the marketplace, type sneak, and then install it. You'll have to reload your ID to take into account. And once you've done this, you'll see a little patch icon here on the left sidebar. And if you click on it, you won't see this. You will see patch asking you to authenticate. So if you have a Sneak account, you can authenticate, and then you can start scanning your code. So here we can see there's a lot of vulnerabilities, and obviously because this application is vulnerable for because we've designed it but yeah, but this is giving you a bit more visibility on the packages that are using and if they have vulnerabilities. But also you have code security section if you want to have a look at if there's any vulnerabilities within your code, which is apart from your packages. And usually we'll give you a few snippets just to improve your code and how you could remediate to those vulnerabilities. And the last one is around code quality, just to improve the quality overall of your code base. Well, let's go back to the open source security block here. So we know that the st package is vulnerable. So let's have a look here. Clicking the little light bulb show the most severe vulnerability. Cool. I'm just going to reduce this and zoom in. So we're right. That's a directory reversal. Good news. Just going to remove this. And here we have more information on here, on the vulnerability. So this is the directory traversal. You have all the metadata with all the CVEs info here. You also have a link to Sneaklearn, and I'm going to talk about Sneaklearn in a bit. So what is the vulnerable package? Which version you want to choose to? So you have 0.2.4. The good news is it's fixed in 0.2.5, and there's a proof of concept. So let's have a look. And with this is helping you having a little bit more context when you code. So we know that the versions prior to this version didn't properly prevent path reversal. So literal dots in the path were resolved out, but URL encoded dots were not. So requests like this one would leak sensitive files and data from the server, and that's the one that I've performed. Obviously, I didn't go up till the etc password file specifically, but you get the idea of the vulnerability. So they also explain what is the directory traversal attack, also known as path traversal. It aims at accessing files and directories that are stored outside of the intended folder. And by manipulating files with the .. sequence and its variations, because in that case, we've actually done a little bit of variation around the .. or by using absolute file path, it may be possible to access arbitrary files and directories that are stored on file system, including application source codes. We've seen this with the routes JavaScript file, config file. We've seen it with the Docker compose YAML file, and other critical files. So the directory traversal vulnerabilities have different type. But in our case, we're having information disclosure. And they're also telling you that the ST package is a module for serving static files on the web pages, but it contains that vulnerability. Cool. So now that we have this piece of information, so I'm going to writing down on my report, giving it to the developer. So now I have the developer hat because I don't want to have this security vulnerability within the code base. So let's fix this. So going back to the package.json, now that I know that, sorry, the ST package is vulnerable, I'm going to update this this version. So I'm going to pop the version. I'm going to close the server, and I'm going to do an npm install. So here, in that case, you can see that the application was created, and the developer team didn't want to recreate serving static files by creating that piece of code. They actually wanted to implement a package to do so, but unfortunately, that specific version had a vulnerability. So let's start again the server, and let's go back to the application. So if I refresh this, hey, I don't have access anymore. Cool. I can just like remove this from my report. This is actually solved. Cool. So let me have a look. Let me go back to the front page. So again, I'm a pen tester here, and I'm trying to tamper with the application and giving my findings to the dev team. So I mentioned when I was, so I can't go back to the path reversal attack because I fixed it. But if you remember, I was looking at some packages and the versions, including one around Lodash, and because I know that around Lodash there's a prototype pollution attack, and I will come back to that one specifically to explain what is a prototype pollution. But I know this one is some of the Lodash version had that vulnerability. So potentially I could tamper with this. And I was looking at specific endpoint indentance, and I was looking at the chat endpoint more specifically. So you can see for now I have an empty array because the developer team are still working on this feature. So it's not really they don't have like a web UI for this. So we're going to do the chat option using curl to demo, because it's still in the development phase. But still, we can actually demonstrate the vulnerability using that endpoint. So I'm on the chat endpoint, as you can see here. And with the piece of code as a user, I am able to create a message. And as a regular user, I'm not supposed to delete the message. But as an admin, I can create and delete messages, which makes sense, because as an admin, I can delete messages. So using the vulnerability from Lodash with the merge function, I'll be able to pollute the JavaScript object and overwrite the permissions to delete messages of a regular user. So I'm just going to go back to the piece of code so you can have a better overview of what is going on. I'm just going to go at the end. So here I'm going to tamper with the chat endpoint. And there's basically two types of user, as I mentioned. There's the regular user with the password, and there's the admin user. And as you can see, that this parameter within the object, which is part of the admin rule, it's not part of the regular user. So as an attacker, potentially what I can do is take this bit of code and try to inject it within the user, so I can delete messages from the application. And also this is possible because there's a vulnerability around the merge function from Lodash. So the underscore is the naming convention when you're using Lodash within your application. So the Lodash.merge is the one that is actually permitting this vulnerability. Cool. So let's have a look and try to perform this prototype pollution attack. So at first, nothing, empty array here. I'm going to start creating, well, first of all, I'm going to do sanity check and do curl get request just to see if I'm getting the same result. Yes, I have an empty array here and an empty array here. So this is the starting point. What I'm doing here is creating my first message. So here I'm using curl to do so. I'm using a put request. This is the endpoint, the chat endpoint, which I'm using here. So exactly mirroring what we have on the CLI and on the application. I'm using content type applications JSON, And the message, the data, will be the piece of code that I've actually, the message that I've showed you. So the regular user with a password, and the message is just hi. So let's send this, and we have back with okay, true. If I refresh here, I'll see the message. Cool. So this is working. Let me just create a bunch of messages. So we have more. Yeah. So we have like ID1, ID2, and ID3. So we have 3 messages. Okay. And as a regular user, I'm not supposed to delete one of these messages. So here, what I'm trying to do is create a delete request using the same endpoints. And with the data, I'll try to delete message number 1. I'm getting an access denied, and this is the expected behavior. I shouldn't be able to delete any of these messages, and actually I can't. So this is great news. I'm getting an access denied. So now I'm going to try to tamper with this. What I'm going to do is sending a put request, same endpoint, content type application JSON. Here you can see the user password, and in the message you can see that I'm using the text with the little emoji here to to show that I'm the bad guy in that case. But more importantly is the prototype pollution that we're performing here. So I'm adding this. I'm injecting this parameter in the JavaScript object, the can delete true, which was part of the admin object. So, and here I have okay true coming back. So actually, this request was accepted. And if I refresh the page, I have the bad guy here. Okay, which is still like a regular user, you can see. Cool. So now let's try to delete one message, because I've actually tampered with the admin object. So here again, I'm recreating the same request with delete, and I'm going to try to delete message number 1. The first time I couldn't because I had access denied, but this time I have okay true. Let me refresh the page, and the first message is gone. Let's do this for the 2 other messages. And message number 3. And if I refresh the page, oh, I only have the hacker message. Cool. So let's see how we can fix this. So I've created a report. I gave it to the developer. Developer is a little bit scared. It's like, how is this possible? Well, the good news is there's a fix for this one, because we know that the Lodash package is vulnerable. So let's have a look here. And I actually gave all of those recommendations on my report because I'm a good pen tester. So what I've actually tell the developer, because there's a few, as you can see, if you click here the scan, you'll have a few prototype pollution. It's actually not in the high, it's actually in the medium. And just gonna look for Lodash. It's this one. So it's not a critical or a high, it's a medium. And let's see. So this is a prototype pollution. Again, giving you the metadata. You also have a link to the vulnerability, and this one has been introduced through this version. It's fixed in this specific version. So it's explaining what is Lodash, which is a modern JavaScript library, utility library delivering modularity, performance, and extras. And you have proof of concept, which is the one that I've showed on the code, is also using the merge vulnerability. And a prototype pollution is a vulnerability affecting JavaScript. It refers to the ability to inject properties into existing JavaScript language construct prototypes, such as objects. And JavaScript allows all object attributes to be altered, including their magical attributes such as proto, constructor, and prototype. So an attacker can manipulate these attributes to overwrite or pollute a JavaScript object. And this is what happened with, I've actually managed to, with the proto, implement a new parameter within the objects. Cool. So let's fix this, because we don't want that in our code base. So if I go back to the package JSON, I'm going to look for the Lodash package and update the version. And here I'm going to shut down the server and do another npm install. Waiting for it to install. Cool. I'm just going to start back the server. And if I go back here, this is now gone. Because as a regular user, you shouldn't be able to tamper with this one. Cool. So 2 vulnerabilities found and 2 vulnerabilities fixed. Let's have a look at the last one, this big input box at the middle. So as a pen tester, I'm assuming that I can tamper with this box using XSS, cross-site scripting attack. And also, having had a look at the application architecture, I know that this application can use Markdown, so I can prettify the to-do list. Cool, which means that I can also use links. And if I right-click here, I actually have I'm redirected to this. Cool. So the links are working. Okay. Just for sanity check, I'm going to try with the usual script. It's not working. So there's a little bit of sanitization going on the back end, which is cool. But let me actually start building a payload based on the markdown. So here you can see I'm using the JavaScript colon protocol and trying to do an alert with patch. And okay, that's interesting. I actually get some sort of response, which is different because here it was just outputting the what I've actually put, but here I only have the closing parentheses. And in that case, I'm checking if there's any sanitization in place. It seems to do some filtering when there's the value JavaScript colon in that case, or maybe a VB script colon, because these are usually vectors of attacks. So I know that potentially, we're assuming that this could work. So let's try with URL encoding. So URL encoding is basically replacing. What I'm going to replace is the colon and the closing parentheses. So the colon will be this one, and the closing parentheses will be this one. Cool. So going back here, and I'm going to URL encode those 2 elements. And now I have JavaScript colon encoded and alert one with the closing parentheses. Let's see. It's completely gone now. So this is sort of a response for an attacker, because usually an attacker will try to craft and build up payload depending on the response that they're getting from the application. So let's continue and let's work on this payload, and let's add the this keyword. And here, because this application doesn't have cookies, so I cannot show with document.cookies, but I'm showing with the document.location. It's basically the same. So here we're using the JavaScript colon and trying to break out of the logic implemented in the backend that is blocking us from hacking this application. And we're assuming that the condition must expect exactly the JavaScript colon protocol. But in that case, we're encoding it and adding this keyword here, which is a valid keyword in JavaScript. And you can replace it with a window or a document. This will work. And the HTML entities and the browser permissiveness will enable this vulnerability. So if I enter and click here, you can see the alert is actually working. So here we have for an attacker, that's the first step when testing an application, to see if there's any entry point to craft a better payload. And also, if I refresh the application, this is an example of a stored XSS, a stored cross-site scripting. The payload is safe in the database. So you might say, Sonia, this is just an alert. And it's like, yeah, that's true. But if we think of a social media application where you have user profiles, so visitors could potentially click on the link on the profile and the data would be sent to the attacker server containing sensitive information. In that case, maybe session cookies. So let's have a look at what is going on with this one. So I know, like writing down my report, I know that the marked package was the one actually including that vulnerability. So let's have a look at the marked package. So if I click on the yellow light bulb here, and I have more information, and yes, it's just like confirming my assumptions. We do have cross-site scripting. So again, we have all the metadata. We have a link to Snake Learn. This was introduced with this version, and it's fixed with this version. Cool. So it's explaining what is the marked package, and also the effective version of this package are vulnerable to XSS, and an attacker could bypass its output sanitized through protection. Okay, that's interesting, because if we have a look at the code here, so we have the marked package that we're using here, and we are instantiating it here. So we've done a little bit of due diligence, setting up the options to sanitize true, but unfortunately, we managed to bypass this. And this is what it's referring to here, the sanitize true protection. So yeah, by using HTML encoded character sets, attackers can inject JavaScript colon code snippets into the output. There's a little bit more information around what is XSS attack, and in our case is a stored one. Cool. So once we have all this piece of information, what we want is to actually fix it. So going back to the package.json, looking for the mark package, updating the version. Just going to close the server. Do another last time npm install. So as you can see for this application, we've implemented 3 packages. Unfortunately, the versions were all vulnerable and implemented a few vulnerabilities within our application. But the good news is we managed to fix them all, which is good. So I'm just going to remove all of this. I've refreshed the page, so that's why this payload doesn't work anymore. Cool. Done. That's great. Oops, just going back here. Okay. So what did we learn here? So a few tools that we could potentially use that I can use as a pen tester, or if I can use as a developer. So we can use Sneak Advisor to check if a package is secure before implementing it into our code base. And if we have a look at, I'm just going to close this here. So for example, the ASCII package. Here you have a little bit more info around it. So this is giving you a few information around several dimensions. So security, popularity, maintenance, and community. It's giving you a package health score. And here you have more information on the version that you could use. Obviously, for the demo, I've used really old and vulnerable versions, but you can use the latest, most popular one, and they don't have known security issues. You have more info around the popularity, the maintenance, and the community behind this package. Let's have a look at marked. So the marked package, here also, again, popular one, doesn't have known security vulnerabilities, quite popular package. You have info around when was the last commit, the last release, and the team behind. Cool. So also you can use, so depending on your workflow, I've used the ID integration, but if you're more familiar with the CLI, you can actually use the CLI to test your query the vulnerability database, and this will let you know the vulnerabilities that you have within your code base. And this is also mirroring what you have here. It's exactly the same. And also, if you use the sneak test severity threshold, this will come back with only the highs and criticals in that sense, because you're filtering with only highs in that sense, if you want to tackle the criticals first. You can also have the visibility on the Sneak dashboard. If you import your project, you can monitor your project automatically. And if there's any new vulnerabilities introduced into your application, you'll be notified. And in that example with Mark, this is from the Sneak dashboard, the web application. If you click on this little green button, you'll be redirected to the pull request. This is if you're hosting on GitHub. Then you can either check for fixing one vulnerability, or you can bulk fix everything if you're adventurous. Obviously, you'll need to check the final pull request if there's any breaking changes, and also this will depend on your workflow. And SneakLearn, I've mentioned SneakLearn a few times, but let me just explain to you what is SneakLearn. I'm going to share with you the link here. So SneakLearn is our online platform, free online platform with interactive lessons. And you, depending on the ecosystem that you're using, you had 5 lessons around Go, JavaScript, C++, Python, PHP, C#, Java, and Kubernetes. So yeah, if you filter by ecosystem, you'll have a few vulnerabilities. There's a new one here. See, clear text storage of sensitive information in cookie. Great. There's a lot of new lessons coming up every week, so that's quite cool. There's also a learning path, and the learning path that we have at the moment is around OWASP Top 10. So if you want to learn more about what is OWASP Top 10, using those lessons, it's like one pager, and you have everything sandbox. So if you don't need to install anything on your machine, you just go along with this lessons to understand a bit more, learn a bit more about those security vulnerabilities. And it actually keeps progress. So you can create an account and you can start a lesson. If you feel it's a little bit too much to digest, you can come back to continue the lesson. It'll keep track of all of your progress. So let's go back to our iceberg, because we've seen only 2 layers. So the third layer is containers. And applications need to be deployed somewhere. So we're using container and static website to deploy our projects. And we have different ways to do so, like Docker, Versal, Netlify, and cloud providers. And we're adding a Dockerfile now in the equation if we're using Docker, which has metadata about your project. So there's an additional layer with modern application, and we're running our application as Docker images, which means that we're adding complexity and we're increasing the attack surface, as you can see with this graph. Snyk can help you scanning your Dockerfile and giving you that visibility, but we'll come back to this. Before, let's have a look at a really basic Dockerfile. I know that's a really basic one, but what could go wrong with this? So there might be some vulnerabilities coming from common software and install time. And I'm going to come back to this image magic package. We're going to do a demo with a remote code execution. Dependencies, vulnerabilities. So installing dependencies during runtime, we would recommend to use the only production flag to avoid pulling dev dependencies and non-deterministic package install. Also, are we looking at security releases? If we're picking a large image, it might have many vulnerable libraries within. I'm going to demo this with the image magic. But obviously, we don't have time for this. So we want tools that can allow us to give us visibility and automate this process. So if you have a Dockerfile within your project, Snyk can actually scan it and let you know if there's any known security vulnerabilities in it. And you can see the current image that you're using. For example, this 10.4.0 with a few security vulnerabilities. And there's some alternatives that you could use potentially to actually decrease this depending on your risk appetite. And you can also use Snyk Advisor. So if I go back here and just change the drop down to Docker and type node, you'll be able to have also that kind of information here. In the tags, you'll put the version that you're using, and you can start comparing with the latest one. It works. Yes. No. A bit slow. Yeah. Cool. So you have the selected tag, and you can start comparing with the others. So I'm going to demo the image tragic and image magic. So the team behind image magic actually created that website called Image Tragic, and Image Magic has multiple vulnerabilities, and it's a package commonly used by web services to process images. One of the vulnerabilities can lead to remote code execution if you process user submitted image. Cool. This is scary. So let's have a look at what we have here. So I've actually created a really simple application, a fancy one. Let me show you my fancy application. That one. Yeah, you can laugh at it. It's just for the demo. It's a really fancy one where we could upload an image to convert it as to a Twitter ideal photo here. Cool. So this is the Dockerfile, and you can see we're using that specific node version. Okay, that's all. And what we're going to do is upload 2 payloads. The first one will actually trick the application, thinking that we're uploading an image, but we're actually creating a file. And the other payload is tricking the application, thinking that we're uploading an image, but actually we're creating a reverse shell. So what I've done, I've set up the scene before this session just to make sure that everything was working, hopefully. And what I have here, I've actually created the image, running the image, and I've set up the remote code execution. So the first screen here is the local static server to serve the netcat package, but I'm just going to reduce this screen because we don't. This one is not important. Those two are. I'm just going to try to. Yeah, cool. The second one is to connect to the Docker container, so I can check who am I. I'm root. Okay, and most importantly, just to show that there's no RT1 file here. So this is like a pristine, clean image that we have. And the last one is to run the netcat in listening mode and wait for incoming connection. So let's perform the first the first payload. So I'm going to go here. Which one is it? Exploit. So I'm uploading the first payload. So creating the RC1 file. So I've chosen the file. I'm going to resize it. Obviously, this one is broken because it's not a real image. But I get the image resizing success message. Okay, let's have a look at our container now. And you can see that it has been created. Okay, cool. Let's upload the second payload, this one. And I'm going to resize that one. And as you can see, I have the little spinning icon here, which is usually not a great sign. So let's have a look at what is going on. So if I do another LSLA, and I'm just going to, you can see that there's a lot of files that have been created here, which is not a great sign. So what is going on here? So we'll have to wait 10 to 20 seconds for the netcat utility to be downloaded from the local static file server, which is the third, this one, the first one, sorry, screen. It'll be compiled and executed to then create a reverse shell that is going to come back here. I'm just going to put who am I here to make sure that I'm back with root and create that reverse shell that will allow us to interact with the local netcat listening prompt. So hopefully I'll get a connection to the container. As I said, it's taking a little bit of time here in that sense. And while is connecting, let's have a look at the again at the Dockerfile, because I've mentioned that if I zoom in, I've mentioned that the image magic package is vulnerable, but I don't see it here actually, and this is quite surprising because I've just fetched the node image, but unfortunately, the vanilla Node.js based image, that specific version, was shipped with a vulnerable image of image magic. So this is where it was here. So basically, if you want to fix that vulnerability, in that case, you'll need to upgrade the Node version. Let's come back to, oh yeah, okay, cool. So I'm root now. That's cool. Let's see, I'm just going to type here which Python they're using. Okay, I'm just going to prettify this reverse shell. Give me a second. Just going to do import pty, let's pwn bin bash here. Bash. Well, hopefully I didn't do any typo. Okay, cool. So who am I? No surprise, I'm root already, you know. But now I do have a connection to the container, so I can do a lot of things. I can navigate through all of these folders. I can try to see if there's any sensitive file. And as a hacker, I can exfiltrate the data to my own server now. I can also put some sort of ransomware to encrypt the data that you have on your container. So let me just navigate some here. Yeah, and I'm going to go back. Yeah, so you can see like I have the root, the etc folder, and yeah, you can imagine what could go wrong in that case if an attacker could potentially navigate through all of these folders. So this was an example for mode code execution. Cool. So we did have we produced that Docker image security best practices cheat sheets with a few advice on preferring minimal based images and also preferring multi-stage builds for small secure images. So basically, during the development stage, you would use larger image because you want to experiment. And when you're shipping to production in that stage build, you will have small and more secure images. So what's the last layer? Because we've seen that at the top of the iceberg, we have the application code. Then we have the open source code. Then we have the containers. And the last one is infrastructure as code, which is an approach to manage your data center server, your storage and networking infrastructure. It's meant to simplify large-scale config and management, and because you're provisioning your resources through code instead of manual processes, and just to make sure that application is scalable and available. So you can make your code as your single source of truth, where you specify explicitly through code all of the infrastructure specification in your config file. You can have version control. You can test and monitor your configuration. IAC is amazing. But the most common vulnerability organization face is cloud misconfiguration. And this refers to any glitches, gaps, or errors that could expose your environment to risk during cloud adoption. And you have a few examples at the bottom of this slide where, for example, the PlayStation Network accounts, 77 million accounts were hacked. For Uber, 57 million customers and driver info were breached via Uber's GitHub Actions and AWS creds, because basically one of their repo went from private to public, and attackers usually scan public repos on GitHub just to actually harvest those credentials, and they managed to tamper with their repo and accounts. So last demo, what I wanted to show here, if you can zoom in. Yeah, so here I'm having a Terraform file where I actually define a few infrastructure using AWS provider. So here I'm defining an IAM account, a password policy, and this is what I'm going to showcase this, hence they'll comment it a bit. I'm also using a few other Terraform to define a VPC, a storage, CloudTrail, and PKI. Cool. So I'm going to do a sneak IC test here. And basically what it's going to do is going to check my Terraform files and let me know if there's any areas I could improve and harden my infrastructure. So here it came back with no critical, a few highs, a few medium, a few lows. Cool. If I have a look at, we can see there's a few issues around S3 bucket settings, CloudTrail, credentials, security groups. What we're interested in for this just this demo is the IAM password policy. So here we see that it should contain symbols, it should contain lowercase, uppercase. Cool. Let's fix this. Well, let's basically remove this. Remove all of that. And rerun another sneak IC test. And hopefully I did fix a few mediums. So basically I've defined IAM password policy. Cool. And if I scroll back a little bit, we can see these rules. So if I have a look more specifically at these rules, here, this is where some of them are defined. So they'll give the issue, the impact, and how to resolve it. So you'll have a few more rules around IAM, and also you have a few more rules around all the services that you could potentially use within AWS, but also if you're using Azure, GCP, and Kubernetes. And these rules are checked coming from the Center for Internet Security, which are basically CI's benchmark list, which are recommendations for hardening your infrastructure and are guidelines, well-known guidelines to harden your infrastructure. Cool. Let's go back here. So now, hopefully, we all have a better understanding, a global understanding of every layer of what is a modern application. So we have the application at the top, which is 10 to 20% of our code base. We have our the open source libraries and containers-based images, which are around 80 to 90% of the code base. And then we have infrastructure as code with potentially misconfiguration. So it is important to have guardrails at each stages of your pipeline to spot vulnerabilities as your attack surface is getting bigger. So here at a demo, during the coding phase, you could use the ID integration or the CLI to have that visibility when you code. The repo stage, this is when you actually raise a pull request on GitHub, and this is where you could test, fix, and monitor. On your CI/CD pipeline, depending on integration, if you're using Jenkins, Circle CI, GitHub Actions, Azure pipelines, you also have that endpoint. You can also set some guardrails, obviously on production and also on registry to scan all the packages. And thus we have that DevSecOps feedback loop, because we want to empower developers to build applications securely within the entire development process. We don't want to have siloed team between engineers and security. So let's see a few defense in depth 30 practices and tech to consider at the OSS level. Make sure to inventory your open source components. Don't give hackers more tools to expand their exploit. Leverage security tools just to improve your OSS security posture in general. Embrace automation because you don't want to do manual activities. Make sure to include your OSS components in use into your security policy. And also you can have that visibility around your packages and licenses that you're using through software bill of materials. At the continuous level, don't run as root. We've seen with the demo what it looks like. With root, the hacker was able to actually navigate through all the your files and folder and just exfiltrate whatever they want. Privileged containers also, you almost definitely don't need it. Drop capabilities, so dropping all and allow only what's needed. You probably don't need SSH and curl when you push to production. Deploy from known sources and pull from known registries only. At the ISC level, secrets, use them, but make sure they're encrypted and have role-based access control applied. Security context, make sure to not set as root. Use also network policy with zero trust, and enforce and harden your infrastructure using tools to have that visibility. So before going, I just want to give you my 5 top tips. The first one is to adopt a DevSecOps approach, or the shift left approach. This aims to detect security issues from day one in order to prevent those to begin with and to resolve them as quickly as possible if they do indeed arise. Address open source vulnerabilities, because we all love open source projects, open source components, because they do offer a great number of benefits, including cost efficiency, but they also expose us to significant vulnerabilities. So when you're using open source software components, make sure to have ongoing monitoring for vulnerabilities, regularly updates and patching vulnerabilities as quickly as possible. They're therefore critical. Automate simple security tasks, because it's virtually impossible to mitigate the endless number of vulnerabilities that exist using a manual approach. So automation is therefore critical, and all simple tasks should be automated in order to allow your teams to focus on more challenging and interesting tasks. Be aware of your own assets. Visibility is the first step toward gaining insights into your organization's security state, as you can't secure what you haven't identified. So knowing precisely which assets makes up your application and software production infrastructure is really, it's key. Security training for developers, developers who are responsible for pushing code into production. So it's critical that we receive the appropriate training from the security team if you want to upskill on your own. Obviously, the training should be tailored to the specific developer's role and security needs, but this is actually a nice segue to a few useful resources that I would like to share with you. So the first one is the Snyk Security Resources Corner, where we have a few cheat sheets on best practice. So because this session was around JavaScript, so you can see here the NPM, React, but we also cover Java, PHP, Ruby, Docker, Go, and other ecosystems. Snyk Learn, amazing platform if you want to learn more about security vulnerabilities with one-pager and hands-on labs. State of Open Source Security 2022. This is a joint effort between the Linux Foundation Research and Snyk. This is if you want to understand a bit more about the open source ecosystems, some metrics and insights just to improve your cybersecurity posture. The State of Cloud Security Reports 2022. This is to get more insights around the cloud ecosystem. What are the risks and security challenges that organizations are experiencing? So, I'm Sonia Moisset. I'm a senior security advocate here at Snyk. I'm passionate about DevSecOps, open source, and cloud security. I'm doing a few things outside of Snyk, but I'm not going to bore you with this. If you want to connect, you can do so with Sonia Moisset on LinkedIn. Yes, a final shout out to the Big Fix. Remember that you still have 14 days actually to participate. And if you fix at least one vulnerability, you can get limited t-shirts, limited edition t-shirts. So yeah, just trying to make a bit more safe for all of your open source projects or pet projects that you're working on these days. This is a good opportunity for you to improve that security posture. And yeah, I'd like to say thank you for attending this session. I also wanted to say stay safe in your journey to cloud-native application security. Hopefully, you did find did learn a few interesting things and how to remediate some of them with the help of Patch today. So yeah, I hope that you did learn a few things. Cool. Let me just remove this. So yeah, this was the session for today. Hopefully you did learn a few things, and you'll have to participate to the Big Fix to fix your security vulnerabilities. And yeah, if you have any questions, just let us know. And yeah, thank you for attending, and see you next week. It will be Vandana. So yeah, see you next week. Take care, all. Bye.